who sell out in the stores? You tell me who flop, who...
Here's our Logger Pro data from our dropping of the ball. As we can see from our acceleration graph right here, I dropped the ball right about here and accelerates at about 9.8 meters per second. That's what this line is right here. You might ask why does it not start at 9.8 meters per second? Well, that's just because we have other forces acting on our ball in real life scenarios like wind resistance and such. Now here we have our velocity of the ball, and as we see as time passes, the velocity goes up. And I think it goes up to about, what's that point right there? It's to about 4.4 meters per second. And then here's our position of the ball, which is pretty simple. It fell about, my hand was approximately 1 meter above the ground, and that's where the ball stopped. Okay, so here's what we can do. In Sketchpad, we can actually theoretically calculate the time it would take for a ball to drop on Earth. With the kinematic equation, tells us from physics that the distance fallen of an object is its initial velocity times time plus 1/2 the acceleration times time squared, whereas v sub I is the initial velocity, A is acceleration, and t is the time in seconds. But in our case, we are just dropping the ball. And as you can see, when we just drop the ball, the initial velocity is in fact 0. So that gets rid of that part of the equation over here. Then we solve algebraically. We just multiply each side by 2. And then we divide by acceleration, and then we take the square root of that, and that will give us our time. And then, as you can see, that's what I just plugged into here. And then we can say in our experiment, we dropped it about 1 meter. So we set this to about 1 meter, and you can see it'll take 0.45 seconds for a ball to drop 1 meter. We can change the distance. And here I just went ahead and I actually graphed the distance and the velocity. We can go to 1 meter. And again, it's going to be 0.45 seconds, and it's going to be about 4.5 meters per second is our velocity. And you can see that on a graph as well. The velocity is about 4.5, and it has fallen for about 0.4 seconds. We can also look at this as let's say we're holding the ball and we want to drop it over this whole interval of 18 meters. So then we can say all of these velocities are just the instantaneous velocities at any given point. Now that was fun and all, but now I want to know how much time will it take the ball to drop on the moon. So then I took my acceleration and I made it changeable in our equation, and so now we can just simply change our acceleration here, and I did a little bit of research, And then I found out the acceleration of gravity on the moon is 1.6 meters per second squared. And then I also found the other planets as well. Now, so we just change our acceleration to 1.66. And then we can change our distance to 1. That's about how far we dropped it on Earth. And voila. Then it took 1.1 seconds to fall on the moon, whereas it took 0.45 seconds, if you remember, on Earth. And then the instantaneous, in this case it's the final velocity, is 1.7 more meters per second. If it's instantaneous, we can just say we dropped it from 18 meters, and then we can move our point, and now our instantaneous velocity is right there. Then I can stop it. Now the instantaneous velocity is 3.94 meters per second. And then I can keep going, and yeah, we can check the instantaneous velocity over a period of over a distance of 18 meters per second, of 18 meters. So I actually decided to write a program where you can just select the planet you want and then the distance you want your ball to drop, and it's going to tell you what time it took for the ball to drop hit the surface. So, and here it is. You just hit and enter. Now we can select we can select 6 planets or the moon. We'll select Jupiter. And you say, let's say it dropped 9 meters, and it'll tell you it took 8.3 seconds to drop. Alright, cool.